Professor in LJ Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject fiber optic communication. So friends, till now you learned about the fundamental related to the fiber optics, the structure of the fiber optic cable, types of the fiber optic cable, pulse degradation, which are the optical sources required to send the information in form of the light through the optical fiber. So now we are going to start the new journey, that is the power launching and the coupling. How to launch the power into the fiber optic cable and how the power, the coupling between the two fiber that is provided. So it is about the power launching and the coupling. Particularly from this video, you will learn about the lensing schemes, fiber to fiber joint, LED coupling to single mode fiber. Now, which are the lensing schemes required? Then, how can we join the two fiber? Which are the technique used to join the two fiber? How to couple the LED light to the single mode fiber? So that we need to learn. So now, the lensing scheme for a coupling improvement. Now, the several possible lensing schemes are there. The first is the rounded end fiber. The second is non-imaging microsphere, that is the small glass sphere in contact with both the fiber and the source. So this way this kind of the scheme that is required. Third one is the imaging sphere, a larger spherical lens used to image the source on the core area of the fiber end, and the cylindrical lens that is generally formed a small section of the fiber. Now, spherical surfaced LED and spherical ended fiber, taper end fiber, ended fiber. So these are the various schemes that is required for the coupling improvement. So here in the diagram, you can see that there are the three particular the scheme that is the shown to us. The first one, that is the rounded end fiber. The second one, that is the imaging sphere. And the third one, that is the spherical surfaced LED and the spherical ended fiber. So now, here you can see that how the particular LED light, that is coupled with the particular fiber. In the LED, the shaded portion that is shown, that is the active area for the LED. So now, this way, how to couple the light. So this is the example of the possible lensing scheme used to improve optical source to fiber coupling efficiency. Now there are some drawbacks of using such kind of the lensing scheme. These drawbacks are, the first one is, the one problem is that the lens size is similar to the source and the fiber core dimensions. Now which introduces the fabrication and handling difficulty. So the first drawback, that is the fabrication and the handling difficulty. The second one, that is, while the taper and fiber is there, the mechanical alignment that must be carried out with the great precision. If the alignment is not proper, the light can go out through the fiber. So these are the various drawbacks of using such kind of the lensing scheme. Next is fiber to fiber joint. This interconnections should be low loss. mean while you want to join the two fiber, the particular requirement is what? That while we join the two fiber, the provided loss that should be minimum. So now this interconnects which occurs at where we found the interconnection at the optical source while the light from the source applied to the fiber. The loss can be there if the problem. Photodetector, same as the source, same as the detector. Within the cable where two fibers are connected, while the larger length of the size required, we need to join the two fibers. So at that time, within the cable where two fibers are connected, intermediate point in a link where two cables are connected. So this is the primary introduction regarding the fiber to fiber joint. The connection can be the permanent bond and it is known as the splice, and easily demountable connection which between the two fiber to join the two fiber, that is referred to as a connector. So difference between the splice and the connector means the splice, that is the permanent bond, and the connector, that is the demountable connection. Now, all the joining techniques for the two fiber are subject to different level of the power loss at the joint. These losses depends on the different parameters, like the first parameter, input power distribution to the joint, length of the fiber between the source and the joint, geometrical and the waveguide characteristics of the two end at joint, and the fiber and phase qualities. So these are the particular the joint between the two fiber. Now in any fiber optic communication system, in order to increase the fiber length, there is always need to join the two particular length of the fiber. So at that time, the interconnection of the fiber that causes some loss of the optical power. So different techniques are used to interconnect the fibers. Now, a permanent joint of the cable is referred to as a splice, and the temporary joint can be done with the connector. So, the fiber to fiber coupling efficiency we need to find in this particular case. So, the fraction of the energy coupled from the one fiber to other fiber, which is proportional to the common mode volume, which is referred to as which is denoted by the M. And the fiber to fiber coupling efficiency eta F, which is given by the M upon ME. So this is the coupling efficiency, where ME, that is the number of the modes that can be emitted by the fiber, and the fiber to fiber coupling loss eta F, which is given to as LF is equal to minus 10 log eta F. So we can write the equation of the loss in terms of the particular eta F. Now next is the mechanical misalignment. What is it? The mechanical misalignment, again that's a major problem while joining the two fiber considering their microscopic size. A standard multimode graded index fiber core that is around 50 to 100 micrometer in diameter, which is the thickness having the like human hair. So a single mode fiber has a core diameter of 9 micrometer. Radiation losses which occur because the acceptance cone of the emitting fiber is not equal to the acceptance cone of the receiving fiber. So magnitude of the radiation loss that depends on the degree of misalignment. three different techniques or the types of the misalignment can occur, which are the longitudinal separation, angular misalignment, and the third one is the axial displacement or the lateral displacement. Now we will see one by one. So now here in the diagram you can see that the first diagram, that is the lateral or the axial misalignment. You can see in the diagram that the axis of the fiber does not match. Due to that, the loss that can be arrived. In the second diagram, the longitudinal, okay, that is the end separation. Fine. So that can be separated by the distance d. And here the angular, there is a theta angular gap is there between the two fiber, and due to which the loss that can be arrived in the fiber. Now first, lateral or the axial misalignment. What is it? The lateral or the axial misalignment that occurs when the axis of the two fibers, they are separated by the distance d. Angular misalignment. The angular misalignment, here you can see in the diagram that the two fiber cores are there, okay, and the common core axis is there, and due to the angular misalignment, the loss can be arrived. Longitudinal misalignment. Longitudinal misalignment that occurs when the fibers have the same axis, but their end faces are separated by the distance s. Now, angular misalignment that occurs when the fiber axis and the fiber end faces are no longer parallel, and the angle theta, that is between the fiber and faces. So it is about the mechanical alignment, misalignment. Now we will do the small calculation for this. So the optical power coupled is proportional to the common area of two fiber cores. So the common area which is given by the expression A common is equal to 2a square a arc cos d upon 2d minus d in bracket a square minus d square upon 4 whole raised to 1 half. So where a is the core or radius of the fiber and d, that is the separation of the core axis. Now the coupling efficiency for the step index fiber, which is the ratio of the common core area to the end face area. So it is eta f is equal to a common upon pi a square is equal to 2 upon pi arc cos d upon a minus d upon pi a 1 minus d upon 2a whole square whole raised to 1 half. So these are the few equations. Now for the graded index fiber, the total received power for the axial misalignment and the reduced equation for this, it is the PT is equal to P in bracket 1 minus 8D upon 3 pi A. So this equation, that is about the alignment. Next topic is fiber related losses. Now what is the fiber related losses? Now there are too many losses would be there related to the fiber cables, and these losses that can be occur due to the geometrical and the fiber characteristics. So these losses are related to what? So core diameter sometimes vary, core area elasticity, numerical aperture, refractive index profile, core cladding concentricity. So due to this, the fiber losses that may be arrived. So these fiber losses are significant for the difference in core radius and the numerical aperture. Now there are the various equations for this. So different core radius, that is The loss is given by the formula LF of A is equal to minus 10 log AR upon AE whole square for AR less than AE. And it is equal to 0 for AR greater than equal to AE. Okay, so different core radius is there, then the loss that can be calculated using the previous calculation. Different numerical aperture is there, then the power loss can be calculated by the formula LF of NA is equal to minus 10 log NAR of 0 upon NAE of 0 whole square for NAR of 0 less than NAE of 0 and it is equal to 0 for N of A, okay, G is equal to bracket 0 and is greater than the NAE of 0. Now, the next that is different core radius index profiles. Coupling loss will be given as. So, LF of alpha is equal to minus 10 log alpha R in bracket alpha E plus 2 upon alpha E in bracket alpha R plus 2 for alpha R less than alpha E and it is equal to 0 for alpha R greater than equal to alpha E. So this is about the equations. Now fiber end face preparation. How to prepare the end face for the fiber? So end face preparation, that is the first step for before the splicing and or connecting the fibers through the connector. Now the fiber end that must be flat, perpendicular to the fiber axis and it would be the smooth one. Okay. Now the technique used for preparing the face and face, that are the sawing, grinding and the polishing. The grinding and the polishing that requires the controlled environment like a laboratory or the factory for performing the procedure. Now for that, for performing this technique, the one technique that is used, it is the controlled fracture technique. Now this technique that is required to cleave the fiber. So here you can see the curved form, okay, the tension that is applied and in between there is a fiber to be the cleaved, you can see, and over here, okay, the blade, okay, that is used, okay. So this technique that is used to cleave the fiber. So these are the highly smooth and perpendicular end faces that can be produced through this method. Okay, so now this method that is also used, okay, and it also requires the careful control of the curvature and the tension. Improperly controlled tension that can cause the multiple fracture and that can be leave a lip or the hackled portion. So again, we need to take care a lot while we are performing it. So now here you can see what is the lip and which kind of the smooth surface that is required, and here you can see the other problem, that is the hackle surface and the smooth surface. So we need to be careful while doing all this thing. So this is related to the various lensing scheme, how to join the two fiber, how to prepare the end face. So thank you very much everyone.